If you turn the page, we've got our key concepts for the day. And then on the page after this, we'll actually start doing some examples. So I'll come back every once in a while and refer to this page here. But talking about what we're looking at today, it says simplifying a rational expression means that if you can be factored, you factor it. And then if you have the same things multiplied together on the numerator and the denominator, you can cancel those things out just like you would a regular number. So what is the simplified form of the rational expression? What is the domain for which the identity between the two expressions is valid? So here's our function, 4 minus x squared over x squared plus 3x minus 10. The numerator can factor to 2 minus x times 2 plus x. The denominator is a quadratic trinomial, and that factors to x minus 2 times x plus 5. It says factor each polynomial in the numerator and the denominator. So as much as you can factor. It's not always going to be binomial times a binomial, but you will try to factor it into its simplest factored form on the numerator and the denominator. Once you do that, the domain is going to be all real numbers except for these two values for which x equals 0 on the denominator, which would be 2 and negative 5. Then it says common factors divide to 1. So first of all, what it's doing here is it's removing a negative from the numerator here and saying x minus 2. It's also switching the order of the values in the binomials on the numerator. The 2 plus x turned into x plus 2. The 2 minus x turned into negative x plus 2. And then from that negative x plus 2, they divided out a negative 1. That's what happened there. And so when this negative 1 was divided out of this negative x plus 2, it matched the numerator and the denominator here with those binomials, and the x minus 2's canceled out. And we're left with x plus 2 over x plus 5 right here with the negative that was factored out from the top binomial right here. So it's the opposite of, or negative, x plus 2 divided by x plus 5. So this divides and simplifies to this particular function here. However, we're not starting with this function. So if we started with this function, here's where it gets a little bit weird. If we started with this particular function and we graphed it, this would only have one value of x for which this doesn't work. And the value of x would be just negative 5. If that was the function we began with. But that's not the function we began with. We began with this one, and there happened to be 2 values for x for which it didn't work. And so even though those two are equivalent, it still has 2 values for which x does not exist because of the original function. Everybody okay with that? So anytime you're listing off domain values, make sure you are talking about the domain values from the original function, not what's left. Because the original one, chances are, will have more values that don't work than the one you end up with. All right, so let's turn the page. We might come back to this one a little bit later. This is just a summary of some of the stuff we're going to be looking at today. But if we turn the page, it says to rewrite the expression equivalent to x minus 4 over x for the domain, x is equal to all real numbers except for 0 or negative 2. So this is kind of what I was saying. So this is the one we're starting with. And so the only value for x that we know doesn't work right now is 0. So what we have to do is basically write the quote unquote original problem, or an original problem that uses x being not able to equal negative 2 as well. So the way that we can do this is, what's an expression for which x equals negative 2? X plus 2, right? X plus 2 means that if we solve this when it's equal to 0, that means x is equal to negative 2. So what we're going to do is multiply numerator and denominator by this binomial. If you multiply the numerator and the denominator by that binomial, that can get us back to the quote unquote original problem before things were simplified. So we're going to take our x minus 4 over x, and we're going to multiply the numerator and the denominator by x plus 2. Does this process feel familiar at all? What does this process feel like? What happens like when you multiply, because this is a fraction, right? We're multiplying by a fraction. We have the same thing on the numerator and the denominator. What is this very similar to? It's a very similar process to something that you did probably back in like 4th or 5th grade. This is the exact same thing that you do to find a common denominator. Right? Like if you're adding fractions or something like that, and you need to find a common denominator, you multiply one of your fractions on the numerator and the denominator by the same thing in order to create a common denominator. That's exactly what we're doing here. We're just doing it with polynomials and rational values, except instead of regular numbers. But the process is basically the same. The idea is the same. So on the numerator, we're going to go ahead and FOIL. So FOIL on the numerator, distribute on the denominator, and we'll be good to go from there. So on the numerator, we're going to get first, that's x squared. Outer is 2x. Inner is minus 4x. And last is going to be minus 8 over x squared plus 2x. And then we can add the two terms in the middle together. And that'll give us x squared minus 2x minus 8 over x squared plus 2x. And that is one possible solution. Yeah. Because x plus 2 is the easiest way that we know where we're going to get -2 for our answer if we set it equal to 0. Because over here it says we're writing an equivalent expression where x cannot equal 0, but because of the function we already know that x can't be 0 because of the denominator just being x. And so the other denominator that would work with this would be x plus 2, because if you solve x plus 2 when it's equal to 0, you get -2. And so that's why we're multiplying both numerator and denominator by it, because now this function cannot equal -2 as well as not being able to equal 0. So we're just including that by multiplying the top and bottom by the same thing. But when you multiply something by the same thing on the numerator and denominator, are you ever changing its value? No, why not? What are you actually multiplying by when you multiply by the same thing on the top and the bottom? 1. X plus 2 over x plus 2 is 1. When you multiply a number by 1, you don't change the value, you just change how that number looks. And so that's all we're doing here. We're changing x minus 4 over x, we're multiplying it by 1, because x plus 2 over x plus 2 is 1, and we're creating an equivalent expression here. So this right here has the same value as the original function or the original expression. It just now includes -2 not being able to be used in that function along with 0. All right. Next one. So that was our first example. So if you're asked to, like, if you're looking here and you're like, well, okay, it doesn't equal 0, but how does it also not equal -2? Just create the simplest expression you can for where it can't equal that number, and then just go from there. I mean, we could have just as easily said, what, 4x plus 4 would also be something we could multiply by, where x couldn't equal 2. Or no, that doesn't work. 4x plus 8 would be another one where x can't equal -2. So we could have multiplied the top and bottom by 4x plus 8, but that's a little more complicated than it needed to be. So the simplest form is just x plus 2. All right, let's take a look at these next ones. So these next ones are just simplifying. So all we have to do here is factor the numerator, factor the denominator, divide out any common factors, and then state the domain based on the original values that don't work on the denominator. So we'll figure out our domain basically after the first step when we look at the denominator, how that factors. So on the numerator, somebody give me two numbers that multiply to 1 and add to 2. Because we're just doing a regular factoring here, 1 and 1, right? So on the numerator, we're going to get x plus 1 times x plus 1. This is our basic like algebra 1 factoring quadratic trinomials. The two numbers that multiply to 1 and add to 2 would be 1 and 1. On the denominator, looks like we've got a GCF down there, first of all. So what can we factor out of all three of those terms first? X, okay. So that'll be x times x squared minus 2x minus 3. So right away, we know that x cannot equal 0 because that x is by itself. So x can't equal 0. That's one of the values of the domain that does not work. X equals 0 does not work. We still have to finish factoring this trinomial. So x plus 1 times x plus 1 on the numerator. On the denominator, we're going to get x times. Now, somebody give me two numbers that multiply to -3 and add to -2. What's that? 3 and 1. Okay, so x, put 3 there, x, put 1 here. Which one's positive and which one's negative? Because they multiply to a -3. There you go, x minus 3 times x plus 1. So our domain is calculated here before we cancel anything out. So x cannot equal 0, x cannot equal 3, and x cannot equal -1. Those are the three values for x that make this denominator equal to 0. So those are the values for x that cannot equal on the denominator. So we'll go ahead and write that in. So we'll say domain. We'll just say x not equal to, I'll go in from least to greatest, -1, 0, 3. So those are our values of the domain that cannot work. Everything else works though. It's all real numbers except for those three. That's the domain. Now we need to finish simplifying this. And in terms of numerator and denominator expressions that are the same, x plus 1 and x plus 1, those cancel out because we have the same binomial multiplied on the numerator and denominator, so those would cancel. And so the simplest form of that particular one, I'm just trying to remember if we need to keep this in factored form or not. So 1 second. Yeah, we can leave this in factored form. So we're going to say equals x plus 1 over x times x minus 3. Including the domain, those are our answers there. We have our simplified expression and the domain. And the domain's a little bit different than what we're used to because the domain here is basically saying it's all real numbers except for these particular values. All right. Check out part B. Does anybody remember what to do on a problem like B for the numerator? How would we factor the numerator on part B? Oh, like synthetic division?
Yeah.
So if we're talking about, so synthetic division works for, yeah, it doesn't really work with rational division as well because the divisor has to be a linear binomial. And so our divisor here is a quadratic trinomial. And what we're actually going to be looking for on this one is on the numerator, we're going to factor the numerator by grouping because there's 4 terms. And so what we're going to do is we're just going to basically cover up the second 2 terms and look at those first 2 and figure out what we can divide out of those first 2. What divides out of x cubed and 4x squared? X squared. Okay. So we're going to have x squared. And then what we're left with in the parentheses is going to be x plus 4. Now, what can we divide out of -x minus 4? What divides out of -x minus 4? Just look at those 2 terms right there. Anything we can divide out of those 2? -1, yeah. And it's good that we're dividing out a negative because if you remember factoring by grouping, the sets of parentheses have to be exactly the same. So if all you did was factor out a 1, this would be -x minus 4 still, but we need x plus 4 to match this one. And so factoring out a -1 gives us that same binomial here, x plus 4. All right, now the denominator, Two numbers that multiply to -4 and add to +3. Four and one. Okay, so 4 and 1. Now, because they multiply to a negative, one of them has to be negative, one of them has to be positive, and they add to a positive as well. So which one's positive, the 4 or the 1? The 4, yeah. And then the 1's negative. All right. So we know right away our domain is going to be all real numbers except for -4 and +1. That's our domain. But we need to finish simplifying this. So on the numerator, we're going to have x squared minus 1 times x plus 4. Because we're going to take our GCS, x squared minus 1, that turns into the set of parentheses here. The x plus 4s turn into that set there. So this is factoring by grouping. It's something that we did back in first trimester. The denominator, we're going to have x plus 4 times x minus 1. Now, at this point, you can see we have an x plus 4 on the numerator and the denominator. Those will cancel, but I'm going to suggest that we don't do that yet because we're not done factoring the numerator. Because this x squared minus 1 is a difference of squares. This factors as well on the numerator. So that's going to turn into x plus 1 times x minus 1. And then we still have the x plus 4. And then on the denominator, we've got x plus 4 times x minus 1. And so almost everything cancels out on this problem. The x minus 1s cancel, the x plus 4s cancel. And we're left with x plus 1. With a domain of all real numbers except for x is not equal to -4 or 1. Any questions on those? So that means, by the way, x plus 1 is just a line, just perfectly linear, but it's like moved up 1. So let's check. I'm just going to type this into my calculator. I want to type in the original because I know what that's going to look like, which means that this one right here should be that exact same line, except there's going to be a hole at -4 and +1. So we go back here, we take a look at our fraction. We're going to say, let's see, x cubed plus 4x squared minus x minus 4 over x squared plus 3x minus 4. And there it is. Here comes our line. The exact same line, it just has a hole at -4 and +1. If we go to the table of values, we can verify that. Look at that, -4 error, +1 error. There they are. So it's a little bit weird that this is a line, but that's what it ends up simplifying to, and that's what it would be. Okay, let's keep going here. So let's see, should we talk about it? Okay, so Bailey simplified this expression by dividing out the x squared terms and dividing out a factor of x plus 2 to get 2 as the simplified form of the rational expression. Is Bailey correct? What do you think? Can you factor out an x squared from the numerator and denominator? No. You can't factor something out if it's part of a sum. You can only factor something out if it's part of a product. So the numerator and the denominator here, you can't factor out x squared because the x squareds are being added to the other terms. They're not being multiplied by the other terms. So if we were going to do this one, actually, let's just go ahead and do this real quick. That'll be x plus 2 times x plus 2 over x plus, what is the denominator? Does the denominator even factor? I don't think it does. And we could use the quadratic formula down here to figure out what the values of x are, but I can't think of two numbers that multiply to 2 and add to 1. You're right, yeah, you're right. That doesn't work either, does it? So yeah, two numbers that multiply to 4 and add to 2. No, that doesn't work either, because that should be x squared plus 4x plus 4 right there. So no, in order to figure out our values of x that don't work here, I think we'd have to use the quadratic formula to actually find out those values of x that don't work, because I can't think of two integers that multiply to 2 and add to 1. That doesn't work. So there we go. Okay. Next, find the simplified form of each product and then give the domain. So the next problems that we're going to do here, A and B, these work very, very similarly to the ones that we just did. It's just a little bit more of the same process. So here's an example of what you should not do. You ready? Don't multiply these out using a bunch of distributive property. That just makes things a lot more challenging and complicated and complex than it needs to be. Just start by factoring. Factor everything on all parts of the denominator, factor everything on all parts of the denominator, and then cancel out as much as you can. So for the numerator here on this first one, x squared minus 16, x squared is a perfect square. 16 is a perfect square. There's subtraction, that's a difference of squares. So we're going to go with x plus 4 times x minus 4. And by the way, we can just keep everything on the same numerator now because it's all being multiplied together anyway. So somebody give me two numbers that multiply to negative 90 and add to positive 1. Multiply to negative 90, add to positive 1. What is it? Negative 9 and 10, yeah. Negative 9, positive 10. X minus 9, x plus 10. Now on the denominator, we saw this on the example, the very first example that was just written out that we didn't write at all. I'm going to reverse the order of these two terms and write negative x plus 9 instead of 9 minus x. So negative x plus 9. And then factoring the denominator here, two numbers that multiply to 40 and add to 14 would be 10 and 4. So that'll be x plus 10 times x plus 4. Both are positive. And the last thing I'm going to do before we figure out our domain is I'm going to divide out a negative 1 from this binomial on the bottom. I'm going to get that negative 1 out of it. So this is going to give us x plus 4 times x minus 4 times x minus 9 times x plus 10 should be over here. X plus 10. Okay. On the denominator, we're factoring out a negative from this first binomial, so that'll be the opposite of x minus 9. And then we've got x plus 10, and we've got x plus 4. All right. So our domain here, the values of the domain that will not work are 9, negative 10, and negative 4. Three numbers for which x does not equal. In terms of what cancels out, let's see, the x minus 9s cancel out, the x plus 4s cancel out, and the x plus 10s cancel out. So the only thing we're left with is x minus 4 on the numerator and then the negative on the denominator, which means that we can just put the negative outside the x minus 4 and have that be our only expression. So this is going to equal the opposite of x minus 4. And the domain is all values of x except for negative 10, negative 4, and 9. Any questions about that? No? Tyson, I can see you're following along well. So, I mean, really, this is the exact same thing that we did on the first two problems. We just factored everything in both fractions. Wasn't really much in addition to it, just more of the same. I would like you to try the next one on your own. Try B on your own, see what happens. One has some finer details that need to be paid attention to than the last one. All right. So if you're not done with it yet, that's okay, but let's have a look here. So on the numerator, x plus 3, that doesn't factor. So I'm just going to write equals, here's x plus 3. What could we factor out of 3x minus 18? 3. All right, so we're going to do times 3 and then parentheses x minus 6 and then times x squared because that doesn't factor either. So this is a little bit of a hodgepodge compared to what we've seen so far, which is fine. I mean, everything's being multiplied together, which is what we're looking for. On the denominator, 4x, nothing factors out of 4x, so that's just 4x. What about 6x plus 18? 6, all right, so times 6, and that'll be x plus 3. And then what factors out of 4x plus 12? 4, so times 4, what's in the parentheses? X plus 3, okay. So in terms of our domain, what values are not going to work for the domain? 0 and -3. Good. The -3 because, well, those are both x plus 3, so those are both equal -3. And then 4x equals 0 divided by 4 and x equals 0. Okay, so our domain is going to be all real numbers except for x equals -3 and x equals 0. In terms of what we can just divide out right away, I definitely see x plus 3 on the numerator and the denominator. So I'm going to divide out one of those, cancel one of those out. And then we're going to be able to do a little bit more in terms of like simplifying and making this a little bit cleaner to look at. So on the numerator, the 3 and the x squared can just be put together as 3x squared. Yeah.
So it's no longer x squared, there is x in the bottom.
That's fine too. Yeah, if you want to divide out, factor out the x here and divide it out with that x there, that's totally fine. And actually, you can go ahead and cancel out that 3 right there and turn that 6 into a 2. And that actually gets rid of all of our reducing right away. Everybody okay with that? We could have put everything together and then figured out common factors, but doing it all here keeps the numbers a little bit smaller, which might make it a little bit easier to deal with. So what we're left with on the numerator looks like x and then x minus 6. So I'm going to put the x first and then x minus 6 after that. And on the denominator, we're going to have 4 times 2, which is 8, and then times 4 more, which is 32. And then we have one binomial of x plus 3. I think that's it for simplifying. I did a little bit different on my own separate paper, but this works just fine too. Anybody get 3x squared and then 96x by putting things together and then simplify from there? So that's what I did the first time, but this is actually a little bit easier for simplifying. All right, so then domain is going to be everything except for x cannot equal -3 or 0. There we go. Cool. Questions there? So, I mean, honestly, I don't think there's much of a difference between these problems here versus the ones we just did. Yes, these are a little bit longer and there's more to factor, but other than that, it's not different. Kind of the same thing with division as well. Division is also not much different. The major difference is there's not pretty much room to work, that could be an issue. We'll see how that goes. Oh, hey, we've already answered this question. Let's just talk about this one real quick. We don't need to write it down, but I want to talk about this because we'll probably end up using the space underneath it to maybe do some work. Why is it important to identify the domain of a rational expression before you simplify it rather than after? I've already talked about that. Why is it important to figure out the domain? Most importantly, what cannot be part of the domain before you simplify as opposed to after?
We find out all of it.
Yeah, because if you cancel everything out and you only look at the answer, you're probably going to miss some of those parts that cannot be part of the domain. Cool. All right, let's look at division. So, wait, that's not division, that's multiplication. Where's the division? Oh, division is next, okay. Find the simplified form of each product and the domain. All right, well, this one doesn't really look any different than what we just did. One thing I would mention, turn these into a fraction. So, put them over 1. That way you know that these are actually part of the numerator as opposed to the denominator. But other than that, not much of a difference happening here. So let's take a look. X cubed minus 4x. I think we could factor out an x from that. So that'll be x, and then we'll have x minus 4. X squared minus 4, sorry. 2x cubed minus 3x squared minus 5x. I think an x divides out of that one as well. That'll be times x, and then we'll have x squared minus 3x minus 5. And then on the denominator, let's see, 6x squared minus 13x minus 5. Oh, this is going to be a slip and slide one. So we might have to do some side work on this one. So I'm going to write this one over to the side and say, all right, that'll be x squared minus 13x minus 5 times, so minus 30. We're going to do the a times c method, slip and slide here. Two numbers that multiply to -30 and add to -13 would be -15 and +2. So it'd be x minus 15 times x plus 2. And then these will both divide by the original value of a, which is 6. So divide by 6 here, divide by 6 here. Simplify each of those fractions. Those are both divisible by 3, so that'll be 5/2. So x minus 5/2. And then these will both each divide by 2, so it'll be x plus 1/3. And then the slide portion of slip and slide is take the denominator, slide it in front of the value of x. And that's going to give us 2x minus 5 times 3x plus 1. So that is what the denominator factors to. Everybody remember this process? No? You might have had a different process for factoring something like this. Some of you probably are used to factoring by grouping using this method. I like this process, which is referred to as slip and slide, just because it basically turns it into a regular trinomial that you can factor normally. And then you just take the original value of a, which in this case was 6, and you divide them both by that. Simplify the fractions, and if you still have a denominator, those denominators slide in front of the x. So the denominator here will be 2x minus 5 times 3x plus 1. Yeah, we are definitely not going to have a lot of room here. Let's just do A because we're not going to have room to do B. All right. So our values that don't work for X, what are they going to be on this one? What values don't work for X here? What can X not equal? So positive 5 halves and negative 1/3, yeah. So 5 halves and negative 1/3 are going to be the values that don't work for the domain. Okay. Let's keep going. Let's figure it about B. This still factors here on the numerator, and so does this over here. And then we can put together the X and the X to make X squared as well. So this is going to get a bit lengthy. So we're going to get X times X. I'll just put these two X's together to make X squared. And then X squared minus 4 also factors to X plus 2 times X minus 2. And then let's see, X squared minus 3X minus 5. Two numbers that multiply to negative 5 and add to negative 3. That would be negative 5 and positive 2. So that would be X minus 5 times X plus 2 over 2X minus 5 times 3X plus 1. And I don't think what did I miss?
It was 2x.
Oh, you're right. It was 2x squared. Okay. Sorry, that is wrong. Okay, 2x squared minus 3x minus 5. So that means we have one more version of this over here to do. So that'll be x squared minus 3x minus 10. Okay. And then we're going to get x minus 5 times x plus 2. Those will each divide by 2. 5 halves doesn't simplify, so that's going to be 2x minus 5. 2 divided by 2 is just 1, so that'll just be x plus 1. Sorry, I messed that one up a little bit. So then over here, the numerator should include 2x minus 5 and then x plus 1. So we do get to cancel out one thing. The 2x minus 5 is on the numerator, and the denominator will cancel out, which is kind of wild. Because there's going to be a lot left in our answer here. X squared times x plus 2 times x minus 2 times x plus 1 over 3x plus 1. With a domain of x not equal to negative 1/3 or 5 halves. And we'll forget about B because we don't have room to solve B. So again, this is more of the same, and by more I mean more. There's a lot more to do, but we're doing more complex versions of the same thing. It's not really changing what we're doing; it just changes the complexity of what we're doing a little bit. All right, the next two. Any questions here before we look at part 5, example 5? If your factoring skills are sharp, this isn't going to be too bad. All right. Now there's a very simple way to turn division into multiplication. Anybody remember the rules for dividing fractions? Multiply by the reciprocal. So write the first fraction the same, change division to multiplication, flip that one over, and then do the exact same thing that we've been doing. So I'm just going to say, let's only do part A here. Let's just do A and forget about B. So we're going to have 1 over, we can factor this at the same time too. That'll kind of expedite this process a little bit. We can factor out an x from x squared plus 9x. That'll be x times x plus 9. And then we can multiply that by, let's see, 3x squared minus 18x. Looks like a 3x can factor out of that. So 3x, and then that'll give us x minus 6 on the numerator. And then on the denominator, we can move around or flip around the order of the x, 6 minus x to make it negative x plus 6. But then we can factor out the negative and make it x minus 6, like that. So basically, I've taken the reciprocal of that second fraction and factored it at the same time, which definitely speeds up the process. And then in terms of what cancels out, any questions about how we got from here to here? First of all, quite a few things changed. We changed the division to multiplication. We took the reciprocal and factored it all in the same step. Everybody okay with that? Is that okay? Cancel out the x minus 6s. Those will cancel out for sure. The 3 up here won't cancel out with anything down there, but the x's will cancel. So this will give us an answer of, looks like 3 over the opposite of x plus 9. Or if you want to, you could do negative 3 over x plus 9. I'm just going to say or negative 3 over x plus 9. Doesn't really matter where the negative goes. As long as you have a negative, it's fine. What's our domain here? What can x not equal? Where is x off limits? Was it 6, 0, 6, and negative 9? Yep. So negative 9, 0, and 6. Now, I will usually write these from least to greatest, but it doesn't actually matter. I just really like to create order to things that I'm doing. Yeah.
How do we know?
If x is by itself, definitely. Or if you have just the number with x, like here, 4x, if it's not being added or subtracted to anything, and it's just x by itself, or it's just like a 4x or a 5x or a number next to x, if you set that equal to 0, x is going to equal 0. So whenever you set it equal to 0, if x is 0, then it can't work. So most of the time that just shows up as x by itself or a number with x without adding or subtracting. Yeah. All right. Now we do have one more problem here, and this kind of ramps things up a bit. So I'm going to try to be as quick as I can with this one. And there is an example in the textbook that kind of explains what's going on here. But basically, with shipping companies use this kind of analysis all the time. Because if you're a shipping company, you want to reduce your costs, right? And so you want to use the least amount of packaging that you possibly can that holds the most amount of stuff at the same time, right? Large volume, lower surface area. That's what is a good thing with shipping, because if you reduce the amount of packaging you use and you can increase the amount of stuff you put inside your packages, you're going to spend less on packaging. You're going to be able to fit more in your delivery trucks, which is going to increase profit. So that's what we're talking about here, just kind of as a baseline for what's going on. So a company is comparing the ratio of surface area to volume. So if you compare surface area to volume, that is a fraction of surface area over volume. So that's the fraction we're going to be looking at, surface area over volume. For 2 containers. One is a rectangular prism with a square base. So here's what I want you to do. We're going to draw a little bit, okay? You guys see the little dots on the left, in the left area? Kind of hard to see on my paper here, but on your paper, it should be pretty apparent that you've got dots there. So a square, what I want you to do is just, as best as you can, put a square on your paper. And so a rectangular prism with a square base just means that the bottom of it is going to be a square. So then what you can do as well is, I'm just going to go ahead and do another square here. Actually, you know what? Let's do some diagonal lines. So go back like 2 diagonal lines on each one of these. So there's like basically connecting 2 dots diagonally on each. Just like that. Connecting 2 dots diagonally. And then you can connect this one up with a vertical line, connect this one across here with a horizontal line. So there's our rectangular prism with a square base. Okay, the other rectangular prism has a rectangular base. Now, it tells us about one side of the base is equal to the side length of the first container. So let's just say that's the one that goes like that. We'll say that's the same length right there. The other one is twice as long as this one here. So that's going to be about like that. And then it also tells us that the heights are the same. So we can basically make these two the exact same height. So this is going to go up here. Now, again, these aren't going to be super great looking just because we don't have a ton of room to work, but it'll work on. So they're right next to each other. Now, it tells us that the surface area of the second container, the rectangular one, is 4x squared plus 6xh. That's the surface area. So that's just like adding up all the sides together. Now, it tells us that one of the sides of the bases is the same from one to the other. So, and because the base of this one is square, if we call this one x, this one right here will also be x because it's a square along the bottom, right? Everybody okay with that? What can we call the height? We can actually see it over here. What is it? H, yeah. So the height is h, and it says that the two boxes are the same height. So this height is also h. This length here is x. What's this length? It could be that, but it says it's twice as long as this length here. 2x. Yeah, let's write it in terms of x. There we go. So we have the dimensions, the length, the width, and the height of each of our boxes. Great. What we need to do now is figure out the surface area and the volume of each box. Volume should be easy enough. Volume is length times width times height. So the volume of this box here is going to be x times h. X times x is x squared. X squared times h is the volume of that box. If we multiply the length times width times the height on this one, that'll be 2x squared times h. So this volume will be 2x squared h. We know that the surface area of this particular one, the rectangular one, is 4x squared plus 6xh. So surface area equals 4x squared plus 6xh. Or hx. xh is probably what I should have written, xh. How do we figure out the surface area of this next one? How many sides are there total on a box? 6. Great. Each side has a matching side that is the same area, right? The opposite side of each side of a box is the same area as the one across from it. So surface area here we can say is equal to 2 times, let's see, the bottom is x times x. So that's x squared. Plus, so the top and the bottom are each x squared. So that's what the 2 is for. 2 times each area of each side. The front is going to be x times h. So that'll be plus xh. And then the left and the right will also be x times h. So that'll be another plus xh. Which would be 2 times x squared plus 2xh. Or 2x squared plus 4xh, however you want to think about that. Everybody okay with that so far? Now what we have to do is we have to compare the surface area to the volume. So it's the ratio of surface area to volume. All right, so next, that's going to be, let's do the square one first. So surface area I'm actually going to multiply this in. So I'm just going to say 2x squared plus 4xh. So that's the surface area for the square base one. So that's going to be our numerator. So surface area to volume is going to be, I'm just going to use the bottom space over here now. That'll be 2x squared plus 4xh over the volume, which is x squared h. So we're comparing surface area to volume. Now on the top, we could factor out, looks like 2x, right? Each of these can have a 2 divided out, each can have an x divided out. So I'm going to write this as 2x times x plus 2h over x squared h. Just like that. All right. Now, what can we cancel out here? X. Okay. Kind of looks like about it, doesn't it? What's that? Only if the h divides out, which it doesn't look like it does. So if we could factor the h out, then yes, but the h doesn't look factorable, so no. All right, so let's see. Okay. So that's going to be canceling that out and canceling one of those out. So that'll give us 2 times, what is that? X plus 2h over xh? Or no, over h. Sorry, over h. Oh yeah, you're right. That was a squared. You're right. Goes down to 1. So that's our ratio there. Okay. Now we have to figure out the ratio for the other one. So what it's asking for, basically what we're doing here is we're doing what we've been doing. We don't need to finish this one. But it says which has the smaller surface area to volume ratio. So basically, which one maximizes, which one uses less packaging per volume is what it's asking for at the end. So that's what we would end up looking at here. Both denominators would have xh. It's the numerators that would be a little bit different. And so it turns out, I'll just go ahead and tell you. It turns out that the rectangular base has a smaller surface area to volume ratio than the square base. We'd be able to find that out by finishing this one up, but we're running out of time and I'd rather just kind of wrap things up. So, is the domain of the quotient different from the domain of the product? Oh, okay, well, definitely. So this last question here, is the domain of this quotient different than the domain of the product? And the answer would be yes, because you'd have to multiply by the reciprocal over here. So we would definitely get a different domain. So once you flip that over, it changes what the domain ends up being. Okay. That is it for our notes. Your assignment, I'm going to get that handed out for you. And here it is. So we are working on the assignments that are called advanced. So that's this one right here. This will also go on your Google Classroom, but if you want to write this down, by the way, I'm going to get your assignment handed out. It's probably best just to write it on the assignment, because that's where you're going to be doing your work, which is right here. Or if you want to take a picture of it, that's fine. This will also be written. These are the problems you're working on. It'll also be written on Google Classroom. So if you write it on the assignment itself, that's probably a better place for it. We'll take a look at the answers to section 4.2 tomorrow. I'll take questions on 4.3 as well, but I'll probably take the assignment for this on Thursday. So give you one extra day to work on this assignment. So this will be due on Thursday. 4.2 will be due tomorrow. If you want to check your 4.2 answers now with these last 4 or 5 minutes, you're welcome to do that.